right, so we're going to do a little lecture today on how to debug. The fact of the matter is, like, it's probably the skill that's most essential, that is most lacking in computer science students. Everybody knows how to write a for loop. It's a lot harder to look at somebody's code and be like, why is it not working right? You know? If I cc to old cc, let's just take this as an example, and our square bracket 10, bold C style arrays. I equals 0, I is less than or equal to 10, I plus plus. If you have a small little snippet like this, you could probably see what the problem is, right? It's easy, just don't write bad code, right? Well, everyone makes mistakes, especially when you get tired. You know, my general advice is to not write bad code, but, like, you know, when you get sleepy, when you get tired, it happens. So let's say you miss this, right? And you let this bug here. And everybody on Discord chat, please say what the problem is here. It's pretty obvious. But you miss this, and it goes into your production code, past code review somehow, and your code's intermittently crashing. You don't know why. Yeah, it's an off by 1 error. It goes beyond the size of the array by 1, right? So there's kind of like three steps. That I would recommend. Step 1 is tooling. So, like, how should you go about debugging something that is crashing or not running correctly? So we're not really talking about compiler errors right now. We're just talking about your code's doing stuff you're not expecting, right? So the first answer I'd give you is tooling, and that is what compiler options are you using? There are a lot of safety features. Now, when I was in your shoes back in the day, it was just like, here's a gun. Go shoot yourself in the foot, kid. We didn't have these fancy pants of vectors that do like boundary checking and range checking. Nope. You got C style arrays and you liked it. There's a lot of safety features that can be turned on quickly, easily, and automatically that will catch a lot of bugs. And so let me list just a couple of them. So number 1 is called ASAN, which is the address sanitizer. If you are transferring to another college, please spread the word about our Lord and Savior, ASAN. Because I've been on this trip for like a while now, and like I send my students out to UCLA and Berkeley and San Diego, and we're like trying to get the word out there. Like, you should be doing your school development with address sanitizer turned on, and you turn it on like this: G++ -f sanitize equals address. Okay, and then, you know, main.cc. Let's put this onto the same line. Okay, so that is how to turn on ASAN. Okay, just like that. -f sanitize equals address. All right, and what this will do, what it does, it will catch use after free, double free, memory leaks, all out of bounds, all sorts of memory errors it will catch. And trust me, if I had this when I was in college, I would have finished my homework assignments a lot faster, because going like one too far out of boundary, or, you know, when you got pointers and you're newing, you're deleting and trying to keep track of all that stuff, it's like, my lord, it could be very difficult. You really had to have good discipline, and you had to actually have a certain level of skill even to be able to write a linked list that didn't like segfault or, you know, have issues with it. After ASAN would be UBSAN, which is the same. It's a sanitizer. It's also a sanitizer. Sanitizers are things that are turned on at the compile time and run at runtime, and kind of observe your program as it runs, and prints errors and kills your program if you do something bad. That detects some forms of undefined behavior. Okay, some, not all of them. There's definitely more kinds of undefined behavior that it will not catch, but it'll do a decent enough job. It's not nearly as good, in my opinion, as ASAN, but it is right up there. I always have it turned on, and you can turn that on with -f sanitize equals undefined, like that. And there's no reason just not to use both of them at the same time. .cling D is what you recommend. .cling D is just like your. What do you mean by use .cling D, Aaron? Okay. Okay. Then there is the safe standard library, which is become Burford or something. It is G++. There. And that is turned on with G++-G. And you can put all these things together, right? You can just create one giant compile. In fact, you can see right here, what I have aliased for you by default turns on all of these things that I'm kind of showing you right now. So you got address sanitizer, you got UBSAN, you got the safe standard library, you got debugging turned on, got a bunch of warnings, all warnings turned on with 2 warnings turned off. The 2 warnings I turn off are unused variable and unused parameter, because when I'm doing development, I hate to be annoyed by it's like, you're not using this variable. It's like, I know, I'm getting to it. You're not using this parameter. I know, I'm getting to it. And unused parameter in particular is annoying when you're doing inheritance, because if you have a class hierarchy, not necessarily all of the children classes will use all the parameters of the parent class, and then it's like, you have an unused parameter. It's like, I know, I'm not using that one. And I'm sorry, And so you have to like turn it off, and it's I just they're probably good to put on, when you're like ready to release and you could find like unused variables in your code. In terms of just general normal development, they're fine to turn off. Fatal errors, max error is 1. Fatal errors means it stops compilation when it hits an error. Done. Pedantic errors means if you're doing things that are borderline, there are these things that are sometimes allowed by a compiler, but they probably shouldn't. Pedantic will turn those things into warnings and then turn them into errors, that you don't do anything that's like borderline. And yeah, okay. So -G is also pretty important. All right. So the safe standard library, by default, the standard library does no checking. Like it's pretty bad. Except maybe outside of like .app or whatever, which is explicitly asking for error checking. Okay. By default, like if you pop off of an empty stack, segfault. If you push front once and then pop back twice on a deck, segfault. Like it'll just explode. And so if you use the safe standard library, the debug standard library, then it will add safety checks to all those different function calls that, in my opinion, should have by default. But the default in C++ is fast and unsafe. I think it should be the other way around. I think you should be slow and safe by default, and then after, like, you've proven to me everything's safe, then you turn off the safety checks, if you need the speed. By default, C++ defaults to fast and unsafe. I think it should be the other way around. It's just a philosophy issue, maybe. But that's why, for all of you guys, I give you a Linux server that has all of my favorite things turned on. Okay? And so it gives you safe and slow by default, and then if you want, you can compile the code. Without these options, you get more speed. Okay. So tooling, and then, okay. So second thing, you should probably, also compile with -G. We're done when doing development. -G turns on debugging information in your compiled data. Okay. So number 2, tooling. Okay, so number 2 would be okay, we're doing debugging, so something's not working right. So number 2 is called see out all the things. Some people will kind of mock people for like see outing things, like I'm here, I'm here. As it turns out, you could probably debug some kinds of bugs actually very quickly by just printing out all the values, right? So if your, I don't know, position isn't updating correctly, you could print position before and after a physics call and see if it moves the way it is supposed to move. Right? It's very simple. Just see how the position, call the physics update, see how the position, it didn't move. Okay. See how the velocity, I have velocity. Why didn't it move? Look at the physics thing. Oh, you're passing a call by value instead of call by reference. Done. Right? Delete all the see out statements. Don't leave them in there for long term, because then your code is going to be just flooded with see out statements everywhere. But for just very quickly doing values like that, it's faster than firing up a debugger. It really is. People, I think, oftentimes underestimate just how quickly you can debug using see out all the things as a method. Professional programmers will sometimes poo-poo it and look down on it, but I can find the bug faster than you, buddy. Just saying. All that matters at the end of the day is that your code works correctly. So, all right. Yeah, so basically for see out all the things, if there's some value that's not working right, you print the value. That's it. Just print the value to the screen. And the reason why I'm mentioning this is because your final homework assignment is doing debugging. So I've given you guys 8 debugging assignments for the final thing. And Crowley and I were talking today, and after looking at all the hard work you guys did on the RPG 42 assignment, we decided not to give you another group project, but to give you a pretty easy solitary solo project. And so use clean VS Code is very good, just fast using cognitive. It's just called clean VS. Yeah, like so. Yeah, so you're just talking about installing the language server. Yeah. So, yeah, seeing all the things actually works quite well. Like I said, you might get looked down upon by people who don't know better, but it's quite fast. All right, so yeah, doing things like language servers and things like that, Aaron, are for like more like compiled problems. Language servers will sometimes catch logic bugs, like if you are doing like a integer float conversion problems. Like a lot of times it'll give you a warning and highlight things you're doing wrong. But for a lot of logic bugs, yeah, the compiler's of no help. You have to actually, run through the process of debugging it. So option 3 is called GDB, or or the debugger of your choice. Right? I typically use GDB. And so what you can do is there's kind of 2 ways of doing this. First of all, if your code is crashing, then you can write a core file to disk containing the contents of memory, and you can load it using gdb a.out core, and it will actually revive your program from the dead temporarily and bring it back to life at the moment of death. So it's not really going to go anywhere. But basically, it's like you bring a body back to life, and it's like, I'm alive again. And then you can actually look at the variables of everything. Like, why did it crash right here? And you're like, I'm in a function that shouldn't have been called by that function. You can backtrace it. You can look at which functions called which functions, and the where you are in main, where main line 70 called this line 30, which called this line 100. And you can see, oh, that variable is not ever supposed to be greater than 100, but it's 200 right now. Why is that? And you can like go up a couple stack frames and like look around and see. It's like doing a post-mortem autopsy of your program. So when your code crashes, a lot of times it's too late to see out all the things, right? Because it died. And you're just like, wait, what just happened? You know. And so if you enable turning on core files, you do so by doing an unlimit. So you type limit, by the way. You type unlimit core dump size, and then that'll enable core dumps. It depends on your own system. If you're watching at home, you might have to do more work to turn on core dumps. Basically, when you seg fault, it'll say segmentation violation, parentheses, core dumped, and it writes a core file to disk. And that core file is basically a copy of memory for your entire program. And so it's got every variable, every value, the program counter, where it was in where it was running, you know, that kind of stuff. So that's very useful. But if you don't have a core file, and we have it turned off by default on the server, if you don't have a core file, then you can just run your program inside of GDB. And then when it dies, you get the autopsy. So you do that by doing GDB a.out. Okay. After it loads, run. And then it'll just run your program inside of it. If your program seg faults, it'll immediately break and be like, here, line 50 on file foo.cc, and the function Bob was called by the function Sydney, which was called by main on line 70 with these parameters, and you can just like look at everything. Okay. So if you want, though, you can set breakpoints. And so you could set, before you run it, you can do something like this. Breakpoint 50. Then the program will run until it hits line 50, then it pauses. And then you can examine the values on line 50. So, so let's see if we can break something. Let's see. I've got all sorts of code here. SDF. Yeah, and you can also feed input into it that way, right? So you can also run your program and redirect input into it, so it loads, you know, all the. Let's do that. Okay, so let's try and add a seg fault somewhere in here. It's very difficult for me to write bad code, so bear with me. This is going to be difficult. Got a lambda here. Let's see, what can I do to cause a seg fault? What can I do to make a seg fault? Sure, I know. That's fine. Maybe. New pointer and delete the pointer. All right, fine. I was trying to think of like how I could break my code. Yeah, that'll work. All right. int r int r equals new int 10 delete square bracket r. Actually, we don't even need to do that. We don't even need to have to go that far. Even easier way. Just make a little array, and we will see out r square bracket. Just go out of bounds. That'll say fault. We're gonna get a warning. Sure, why not? Okay, cool. Compile. Run. 10 by 10. We'll put a circle on the map. 5, 5, the radius of 2. Put an asteroid at 0, 0. Asteroid at 8, 8. And there we go. We got a segfault. Okay. So notice there's no core file because core files I think are up on the server by default. So yeah, you don't have to mim copy. You don't have to do anything. Just go out of bounds. It'll die. So do we have address sanitizer turned on? We do not. Okay. So let me show you several different ways we go about debugging this thing. Okay. So first of all is using tooling, right? We just talked about that. CC flag -f sanitize equals address, like that. And we will compile it. Make clean make, run, and we can see here address sanitizer is mad about something. You know, I think let's not use address sanitizer right now. Make clean, make run. Let's do this. Let's just do this. Okay, GDB a.out. Nope. Try again. Let's see if I can type properly this time. GDB a.out. Run. And we'll do a 10 by 10 and just hit quit. And there we go. We crashed. Okay. So it's telling us on line 65 of main.cc, this is bad. We did something bad here. Okay. And so we can like print R, and we can see that R is an array that's got some values in it. And also, by the way, it's only 10 big. And we're trying to access element 100,000 out of the array. So, you know, there's your problem, right? If we wanted, we could do something like breakpoint on line 50 and hit run again. Yeah, let's start from the beginning. 10 by 10, and an asteroid on 1, 1, quit, and then boom, right here. So, switched. Yeah, that'll work. Okay. So you can see I hit Control X, Control A to switch into TUI mode. You can also launch a GDB in TUI mode. TUI is text user interface. So I set a breakpoint on line 50, and so now that I'm here, what could I do? Well, I could do something like I could go to the next line, and I can hit return, and it'll go to the next line again. And then let me see what value I has. Print I. I is currently 0, which it should be because it's our first time through this loop. Let's print the value of J. Cool, it's also 0. Neat. Go to the next line. Oh, sorry, go to the next line. And we can like print closest. Its value is 10. We'll go to the next line. And go to the next line, go to the next line, and then we will print closest. Again, it's now 1.44. So we found the nearest person to us is 1.44. Sounds about right because we put in 1, 1, right? For the, we do that? Like 1, 1 for the asteroid. It then converts it to an integer, which is going to drop the 0.4 off. So we can print the value of D. It's 1, correct. So then it's going to see out. It's going to see out D to the screen. And then we come here and it dies. So you guys see how that works? So I can print any of the variables, and I can just sit there, and if it's not dying, I can just run through the different loops, and I can look at it as it's doing all these computations, seeing if the nearest object is being computed correctly, and I can just sit there and, you know, look at the numbers and print them out and see if they match my calculations, what they should be. If I get a crash like this, I can type backtrace or BP for short, and it'll tell me which functions called which functions called which functions with which parameters. As you put into TUI mode again, Control X, Control A. Or you can run GDB with, I think it's TUI? Something like that? Yeah. So you can just tell it to launch in TUI mode like that. And then there's different commands. There's Control X, Control 2. So you can like show the assembly, you can show the source code, look at the variables. Let's see, let's break on line 30, whatever, run 10, 1. And so you can actually look at the registers as you're going along. You got your C++ code, you got your register code, you got the console output. So you can kind of configure. It's not super, configurable, but you can configure it to a certain degree where you like have like the values you're looking for up there and stuff. So, yeah. So GDB, super useful. Oh, let me take that out. So I do not want this in there. Make clean and make. Let's rebuild this. Okay. Yeah, GDB is great. And I could have done the same thing by couting all the things. Like I'm here, and you could figure out fairly quickly where you're crashing. Usually if I'm crashing, I just use GDB. Because GDB will just run until it crashes, and then it'll tell you immediately, line 57, that's your problem, and you can backtrace and look at all the values. But for things not working correctly, like if it's not returning the right nearest asteroid or whatever to that point, I might very well just out all the things. Like I'm at grid location 00. The nearest person to me is 1.4 away. I'm at grid location 11. The nearest location to me is -9 billion. And you're like, wait a second. It's not right. It should be 0, And so you just go, you just run the program. It spits out all the numbers. You look at it. You're like, that's wrong. Oh, I'm not handling 0 properly. I need a less than or equal to instead of less than. Done. You fix it. Whereas in GDB, you can sit there and go through all the loops, and you're like, okay, I'm at location 50, 60, 70, And a lot of times when you out things, you get all the numbers you want real fast, you fix it, you're done. Don't let people talk down at you because you out all the things. Sometimes that is really the fastest way. Now, in real life, a lot of programs don't have out, right? You don't out something when you're writing Microsoft Word, but guess what? There actually is kind of a out. What we use, like if you do mobile developer tools, there's a console, and so when you do JavaScript can actually print things to their version of out. And then if you're in a program like you're making Starfield or something, it's quite common to write to a log file. And so they probably find one in my games. I don't know if I browse around a little bit. Let's see. Here. Like it's pretty common, like to see just random text files, like in a local directory, and they basically use the text file like they're using cout, right? So instead of printing to the screen, because you don't have a console, you don't have a cout. Instead of that, they just create a little text file. Like here in Steam, you can see there's a crash file there that holds probably text, and there's a JSON file here. And if we go into let's see if we can find something. Search for a log file or something. I'll let that run. Okay, do you guys have any questions about debugging? What you're going to be doing is, and I'll put this on Discord for you. What you're going to be doing is you are going to be given 8 these are not, they look like they're named final, right? Because they are named final. This has nothing to do with your final. These are old final questions that I'm giving you. And so I used to make students do debugging during the final. And so these are basically like several years worth of debugging assignments that you were expected to do within half an hour or so in real life. So none of these things are supposed to really take that long. What you got in each one of them is a pair of bugs. So there is a windowed projector source. Thank you. Okay. So inside of each one of these, there is one compiler bug and there is one logic bug. Now, in 41B, there I think is another issue, which is that there's this really old version of my read library that has a function called read integer. That is now just called read. So you're going to have to change. You guys all see this? Change read underscore integer to just read. That's not one of the bugs you're supposed to find. It's just actually an actual bug. So you have to fix that in addition to the actual compile bug in here and the logic bug. So a logic bug means it does not run properly. Okay. So for example, if I have code that tells you to multiply all the numbers in a vector together, and it starts with 0, and then it multiplies each element times that one, you're going to get 0 at the end, right? You need to change that from 0 to a 1, and then it'll multiply them all together successfully that way. So each one of these 8 folders here has one, except for B, which, as I just showed you, you got a bonus. You got bonus debugging on that one. Each one of them has one compiler bug and one logic bug. You have to fix the compiler bug first, because what's the point of having a logic bug fixed when your code doesn't compile? So all of these are auto-graded. However, none of them have test cases for you. So you have to debug them by looking at the README file. The README file will have all the information you need to know. It should print this when this is the input. And so you will have to test them thoroughly yourself. You're going to be given the knowledge that there's only one, except for in 41B, one change to make it compile, one change to make it run correctly. And the changes are usually on the order of changing a 0 to a 1, or less than to a less than or equal to, or points to left instead points to right. One of these is a binary search tree one. So if you find yourself like rewriting the whole thing, like you're probably doing it wrong, right? You are doing it wrong. You only need to change like this much code, right, for the compile bug and for the logic bug. Now, for those of you that have not had me in CSI 40, nothing I did this semester is nearly as bad as what I put my students through last semester with this. Do you remember which one it was, Luke? It's like midterm 40B, maybe. One of them it was just like all emoji. Another one has the Greek semicolon in it. The Greek question mark, rather. So for those of you that don't know, because this one here might have made a reappearance. The Greek question mark looks like a semicolon. Yeah. So semicolon and the Greek question mark are not the same, according to C++. To everybody else, it looks exactly the same. So basically, this prank here might have made a reappearance for one of the debugging assignments. But there isn't one that's like completely degenerate like last time, where it was just like all emoji and things like that. I don't have anything that bad. I will say there is one Greek question mark in one of those 8 folders out there waiting for you. Could you use namespace? You could use, like, you could probably hashtag define it, maybe. I don't know. Ironically, the emoji one wasn't too bad. That's torture. That's why I'm telling you guys right now, because not everybody had me for CSI 40, so just so you're adequately prepared for your task. There is a great question mark. So, yeah, one compile bug, one logic bug per one, and then I want you also. This is also very important, guys. I want you to write down the bugs instead of just fixing them. I want you to actually write them down. And the reason for that is because, for one thing, you can make the code compile by just deleting everything. Right? It's like, this whole section sucks. I don't know. I just delete the whole thing. Look, it compiles. You're not going to pass the logic test, but 1 point's better than 2. And so I've had students just turn in like an empty int main, nothing in it. It compiles. Yeah, get 50%. So rather than encouraging that behavior, you'll actually have to write down what the bug was and submit that on Canvas. And you'll have until Monday to do that. There is not going to be a final group project. That was going to be a 200-point assignment. Instead, you guys get this, which is going to be a 16-point assignment. Each one of the 8 debugging assignments is 2 points. One for the compile bug, one for the logic bug. So it's an easy pickup of points. It's 16 points. It's more than a normal homework assignment. And they're like designed to be done during a final. So they're not like these massive bugs. Like they're all like, oh, I see, it's missing a parentheses here. And they're not like things that are supposed to like, cause you to chew off your fingernails and stuff like that for an hour. They're just all pretty straightforward stuff. So okay, that's your final homework. So no more programming. The only other thing I want to mention is the final is coming up. The final will take place during the normal final hours. For you guys in the online section, you'll need to be online for it. We will do it live, and for the people in person, it'll be in person. We will have a lecture on dynamic perming on Wednesday. We'll do a final review on Friday, and that's it. So, yeah. So I've got summer on my backdrop here. You can almost smell summer approaching. So getting close. And as a gift to you guys, nothing hardcore at the end of the semester. It's coming up on finals week. It's like, I'll just give you guys something fun. And these debugging assignments, let's be honest, are fun. And like I said, it's a very valuable skill. Most students struggle with debugging, and so this should give you lots of practice doing it. The end is nigh, very gracious. You are welcome. So, is the last group ready to present? If not, peace.